Good afternoon. Can everybody hear me okay? I'm going to probably come at you from left field because I'm going to talk about kind of K-12 education and in particular working with teachers in terms of developing a professional development program. And Dave asked me to kind of talk about it to give you a context in terms of thinking about what you might do as a group and as a community in terms of drought education, if you will. So I'm going to share a little bit about our program that we've been working on, and so two things. I'm going to kind of go over kind of the processes that we've engaged in terms of both developing the team of our stakeholders and as well as preparing our program in terms of working with teachers. And at the same time, or a little bit later, I'm going to talk a little bit about some of the challenges we face in terms of dealing with climate. And so, as Laura mentioned, climate change tends to be the double CC negative word these days. And so we approach it from a climate science and or a climate system perspective, and I'll share more about that in a little bit. Just quickly, the goals for the project, first of all, is to develop a resource, a teacher professional development program that, if you will, trainers of teachers can use to enhance their understanding about climate systems and in particular climate change, and then providing them with some tools and resources that they can implement in their classroom to better help their students understand climate science, climate system. And in addition, our team is also looking at how we might work with the general public in terms of helping them better understand a climate system. Second goal then, after we've developed our program, is we will do some local community implementation, and for us it's kind of our field test. We'll collect some assessment data on how well the implementation goes, and then based on that data we'll kind of revise the program. Then our kind of towards our conclusion of the project is we're going to host a kind of a regional conference where we can disseminate the program and the resources to those interested in conducting additional training for teachers around the Midwest. So we'll kind of disseminate the project through that means. And then we also would like to establish kind of a network of trainers, if you will, through a climate science education network, so that when we're finished, the individuals involved in our project and those individuals have gone through the professional development will have links to each other and hopefully can carry on the program on their own and independent of our assistance. So one of the key processes in getting started is identifying who are the major stakeholders that would be involved in such a project, or who are the major stakeholders that we would be interacting with in terms of our professional development program. So we needed to bring in experts in climate science, weather, and so we have Dave as our co-PI, brings in the climate science expertise. Adam brings in background in terms of weather and climate as well. Obviously, if we're going to work in the K-12 arena, we need to have teachers involved to provide us their thoughts in terms of what happens in classrooms and in terms of what happens in teacher professional development. So we have two teachers involved in the project as well, Mark and Ted. There are also a tremendous number of informal educators out there from museums, naturalists, etc., that do teacher professional development or who work in schools. So we've also involved several key informal educators who are Mary and Jan, and then Hans comes from kind of the extension area as well. And so we've tried to identify individuals who reflect the kinds of stakeholders that we will be working with. And of course, I'm supposed to bring some expertise in terms of teaching and learning in the K-12 environment and teacher professional development. Kind of the process we went through in developing the team. The first step is trying to build community. Most of these people did not know each other, and so we had to engage in some kind of small scale activities, if you will, to help them become familiar with each other, to get to know each other, understand how they each contribute to the project, and so in a sense building relationships. So we involve them in getting to know each other and getting to know ourselves. And then Dave and I ran him through some series of experiences where he would talk about the climate science side of the project. I would then follow modeling some pedagogical approaches or ways we could teach others about climate science, the climate system. And so through that process, we began to develop a common knowledge base and bringing everybody up to speed, helping the informal educators better understand the science, helping the scientists, in a sense, better understand ways you can interact with teachers. And so we developed a common knowledge base. And then from there, that also guides their thinking in terms of brainstorming out a conceptual framework. So from there, we, as a group, worked individually. We then worked in small groups, and then as a whole group to identify a framework. And the conceptual framework is necessary to guide what our program looks like. So what do we want individuals to know about, in this case, a climate system, or in your case, might be about drought. And then from there, we identified the kinds of materials and resources we can use, modify to build a program. And then we had several sessions where we went through those. We critiqued what others had done, what others had found, and suggested ways in which they could be revised to meet the program. And we are now in the process of practicing, if you will, by doing some local implementation and then revising the program. And then hopefully we end up with some additional local implementation, the dissemination, and then as always, assessments are part of the big project. So it's a big picture, it's infused throughout. So that's kind of the process in both developing the team and the program. Some themes that came out of that for the framework. The big idea, of course, being climate system. And then, believe it or not, there are individuals out there who have no idea about what the difference is between weather and climate. So that's an important aspect to address. And then, of course, looking at what are some of the key concepts to a climate system, and that's looking at the energy budget. And we also know that individuals get confused quite a bit between global warming, climate change, and climate variability. So that's also a part of the program. And inherent in all of the phases is the idea of integrating data or both anecdotal as well as quantitative data. And then the ultimate end of the project is to have individuals think about ways in which they can take some personal or community level action related to climate change. For most, because it'll be teachers, it'll be coming up with ways in which they can implement curriculum in their schools. All right, some challenges. Not surprising, time and complexity. Time is a big issue in that if your program is too short on time, you cover very little, and your teachers or participants leave the project not really having developed an understanding. But at the same time, if your time frame for your program is too long, your lack of attracting teachers or others to your project declines, and so you have less of an impact. At the same time, climate change is an extremely complex topic, so we can make it very complex, in which case most teachers would leave the program with little understanding, or we can make it very simple, and at the same time they would leave the program not having developed a sufficient kind of knowledge or understanding. So it's a delicate balance between the length of your program and the focus of the content of the program. For teacher development, it's not a 16-week course. You're going to have, at best, we might have a series of 8-hour workshops that we'll be able to engage teachers in. So what are some solutions? The first thing is focusing on big ideas, and that's where climate system comes into play. Then what are the key concepts surrounded around that big idea? I like to think of it in terms of guiding questions. What are major questions that you would like your, in our case, teachers to be able to answer when they leave the program? So it could be as simple as what is a climate system, what are those components of that climate system, and how might a change in that system affect climate? So we're contextualizing climate change within a system. The other thing that's crucial is linking abstract ideas to the concrete, giving them some physical experiences with the scientific ideas, and then of course contextualizing that experience, and that can be through a couple ways. For us, one is contextualizing climate change as part of a climate system, so you're looking at the bigger picture, and the other way is making it more relevant to their personal lives and their local community, so you can contextualize it in several ways. So an example, in terms of understanding the energy budget, in particular looking at albedo, the absorption and emission of the sun's energy, one can do a short, very easy kind of demonstration where you have a series of colored construction paper, and you use a light meter, and you can very quickly calculate the different albedo levels of those different objects, and those different objects can represent more abstract things, if you will, in terms of models. So you can relate green construction paper to vegetation. We could link blue construction paper as water, and you can link white construction paper as clouds and as snow and ice. So you can make the more abstract concrete and compare and contrast the findings then to the scientific model, if you will. So it's thinking of ways we can engage people in using equipment or using objects and materials. The second challenge is knowing what your audience knows or understands. And for us, it's looking at what students know or understand about climate change. And from our work and from the work of others, we can construct a generalized model about the way they think about climate change. And it's basically pretty simple. It's either the burning of fossil fuels causes an enhancement in the greenhouse effect, which, by the way, is a human-caused process if they don't even understand that it's a natural process, and that leads to global warming, and for them that's pretty much a climate change, which is an extreme increase in temperature. And so they understand it as being we're going to get about 10, 20 degrees warmer, and as a result, death and destruction. And there are still some that have this confusion between the greenhouse effect and ozone. And so we can see what the general conception is, and then from there we can come up with some solutions. And so in the last couple of years, we've been thinking about, instead of focusing on helping students understand climate change, we should focus on helping them understand a climate system and how things change within that system affects climate, and then how the different components function back and forth as feedbacks. And so now you're thinking about climate change outside of just carbon dioxide and greenhouse gases. You're trying to get kids to think about it, and adults to think about it in terms of the changes in albedo as well. And so it's thinking of the big picture. One of the other things that I like to do, I should have maybe done it with you, is I often like to give teachers, put them in groups, give them markers, and I ask them, draw me a climate system. Tell me on that piece of paper what you know about how our climate works, how we get climate, what are the components, what are the factors. And they do their little drawings, and we do some sharing, and we get some things like this, and they have some pretty good ideas. So again, I'm making it more concrete. I'm also eliciting their ideas that we can build from, and then we can discuss the different ideas that, in this case, teachers have about a climate system. And to even make it a little more, to connect the abstract, if you will, then I show them this, or any other kind of diagram. And then we discuss the similarities and differences between a scientific model of climate system and theirs. And so they can begin to kind of challenge their own thinking. So again, trying to make the abstract more concrete. Let's see. We also know what kids know about the greenhouse effect. And we can construct some models. And even the best models tend to think of it in terms of this layer of carbon dioxide, or this layer of greenhouse gases in the environment, or up in the atmosphere, and that this layer does either one of two things. It lets the sun's energy in, and then traps it, warming the Earth, or it lets the sun's energy through and then it just bounces back and forth between this layer and the Earth, warming the Earth. Some think of it as simply gases, again, the ozone idea, and then some, about a third, have relatively no understanding. They think of it as a greenhouse. So again, if we know the conceptions that our audience has about the topic we're trying to work with, we can design experiences for students and or for teachers to help them address these issues. Now the other challenge, these are textbook diagrams, supposed to be conceptual models of the greenhouse effect. One, this is a junior high text. This is a high school text. And if you look closely at these models in these textbooks, you can see very similar ideas. Kids see a layer of gases, energy enters, it bounces back and forth. It's belching smoke and pollutants that create the greenhouse effect. And you and I, because we have a more developed background, we understand what the different colors are to represent. And in this case, well, down here the yellow is infrared, the red is infrared, the visible light. Visible light students don't pick up on these colors. And so color becomes an important issue when we develop materials. So we can also do physical models. So this is the standard kind of activity where kids set up two systems to look at, quote, the greenhouse effect. But again, you can see how the physical model that we use can also reinforce general ideas about trapping and bouncing and reflecting of the sun's energy. And so what kids really modeling are greenhouse. And so again, we're building that idea of a greenhouse, not an idea of a greenhouse effect. So, well, this is a nice starting point, okay? If we do physical models, we then have to relate those back to conceptual models. We then have to ask kids to compare and contrast this model to the scientific perspective of the greenhouse effect. What is similar and what is different? Okay, I'm running short on time, but we've done some similar work in terms of looking at kids' ideas about the water cycle, probably more something you're more interested in. And generally, very, very basic ideas. This is 4th grade through 12th grade, and these models, there's no difference across grade levels. So you can have a 4th grader that has a very more sophisticated view, and you can have a 12th grader that has this very basic view. It's a river or a stream. And so again, if we look at these, we can then think about ways we might better help kids understand drought, how they might better understand the water cycle and its role in that process, and then linking it back perhaps to a climate system. And then I just pulled a quick diagram. This is a better one. Actually, most diagrams in K-12 education simply show phase changes where you have evaporation, condensation, and precipitation. This one at least has infiltration and runoff. So, kind of to jump back to climate, one of the things the challenges we face is that, hey, we got 15 inches of snow last night, or it's now 110, so climate change is either happening or it isn't happening because we experienced some weather event. Okay, so the weather event itself becomes climate change, and as we know, that's not the case. And at the same time, we can't keep them in school for 30 years to experience 30 years of climate, of weather. Some of them may actually be there for 30 years, but so it's okay for us to measure weather, to collect weather data, but then we need to look at that weather data in some kind of long-term context. And so, again, bringing the concrete to the more abstract, collecting daily weather, comparing that day's weather with the historical data. We can then begin to see how it's above or below the average, how it matches with the trend, how it deals with climate variability. So we can also begin to see that weather is up and down. And so we can pull data from, as you all know, from NOAA and so forth, and we can look at temperature, we can look at precipitation, and so we can collect real data, compare it to historical data, and begin to try to make some sense out of it. And so just to kind of wrap up, what might some of these things be for you in terms of thinking about your drought education? First of all, building a community and network, identifying key stakeholders, the movers and shakers within those groups. We selected Jan and Mary to be in our group out of all of them because I know they do a lot of work, okay? So picking the people that will get things done, then as a group developing a plan, a strategy, what you might want to accomplish and how you're going to accomplish that. Looking at what are the educational needs of your stakeholders, what do they need to know, what do teachers need to know, what materials do they need. Part of that is looking at what's out there. As far as I know in K-12, there are no real drought education experiences. The closest will be water cycle. And then identifying the kinds of misconceptions that individuals hold. And so with that, I'll take questions.
Thank you, Dan. Question for Dan?
Yeah.
Please.
I'm wondering, in the current curriculum,
Mhm.
elementary or junior high school, do they talk about events like flooding, these disasters, hazards?
It's hard to give you, I don't have any data or anything. My gut feeling is that,
I should know because I have kids in school, but I guess I've
Yeah.
never looked at their textbooks.
yeah, again, I think as Laura mentioned, I think if there's anything in a textbook that deals with a hazard, it'll be an earthquake, it'll be a tornado, and it might be a flood. I can't recall anecdotally ever seeing anything about drought. I can't ever recall seeing anybody ever teach anything about drought, but I've seen them teach about the water cycle, obviously.
My thinking is, the reason I asked that
Mhm.
question is, I remember they were doing with water cycle,
Mhm.
and so I wonder if there is a linkage in the material already. If not, maybe that's the additional information that should be provided. That you have this system that works, and you observe certain things. How different phenomenon that you observe, or the kids observe, will lead to certain results, like flooding, like droughts. So I don't know if that's a way to approach it, or.
Let me ask an appended question. Are you expected to develop curriculum materials?
Am I? No,
For this to achieve what Carol is talking about?
well, I think if you're interested in doing that, yes, you would need to develop educational materials and/or a curricular program that addresses what you're asking.
Or should we, add this to the earth science curriculum that they may already have?
It could be infused or added to existing programs, like the water cycle. It's a matter of perhaps maybe, to me, I would approach it from the climate system and how is drought a part and the water cycle part of that. And I can tell you that the climate system is not taught in probably K-12 education. So we started with the climate system, then looked at how water circulates amongst those components of the system and how changes in those concentrations might, and the redistribution of those concentrations, that might lead you then to obviously droughts in some cases, floods in others, and then you can bring it in that sense. But I'm just brainstorming here.
This would be something Doug and Mark would also comment. In NIDIS, there is an education knowledge component. And what is the level that is being targeted, and is there something formal being developed? Is it like, for lack of a better word, a drought module that graduates on graduate students hey, and if not, what could be done?
It does be correct.
Maybe you anticipated my question.
I was actually one of the co-chairs of that committee within that, so I believe Doug was. From my perspective at the University of the Drought Center, we have a K-12 education component that's the most hit thing on our website
Mhm.
The number one thing is waste decibel research by students.
Yeah, that would be the one, yeah.
Dave Goslin at the university has had a large Toyota grant that's worked with developing some modules, of which I think one might be Drought, that's,
Okay.
I think also based on climate and water system. I don't know if you know Dave Goslin or not, but they had a project called NESEN, N-E-S-E-N, that was to train teachers in Nebraska to get that into their curriculum. The problem is the curriculum is so stringent on aptitude and the testing that they have to be standardized. And my wife's a teacher that they have to really struggle to find a way to
Mhm.
niche that in there. But we didn't really talk about it on the panel yesterday. But education starts with our youth. I mean, they're the next decision makers and all that good stuff, but it's not addressed at the K-12 level. And I don't know of anything at the real graduate level outside of a class might have that as one component of a course they teach under climate. Like my case does with climate society, where Droughts work into that, but it's not the main focus at graduate or undergrad.
Yeah, I think you mentioned a good point in terms of K-12 these days, and that is both the curriculum standards and testing, and that's particularly in Indiana has become even a bigger issue with performance-based teacher assessment that starts next year. So if it's not on the standards or if it's not in the curriculum, you got another challenge. Yeah.
In what mode do you go by? You train the trainers,
Mhm.
you bring in groups of teachers to the
Right.
university and talk to them about, in what
Right.
mode do you go?
Right. Our plan here is to, once we have the team prepared and kind of a network in place, is that those that are interested in doing teacher training on climate system, climate change, we would then bring them for our dissemination conference and put them kind of through the ringer, if you will, put them through the program, prepare them to take that program, then back to their local communities and do teacher training or working with the general public basically in their local community. So it's kind of this pyramid scheme, if you will, reversed. We have a small group and we want to go backwards. So,
Any other questions for Dan? Thank you so much.
yep, thank you.